Okay, so for this problem, we have our player, that's the smiley face, and we also have the ghost. And I said the player will be max and the ghost is going to be min. And the goal of the player is to get into bed before it can get captured by the ghost. On each turn, player makes a move, up, down, left, right, and then the ghost makes a move, also up, down, left, right. The stairs should be treated as regular spaces, nothing special, and the ghost cannot move into the bed square. All right. And the game ends when the player gets into bed and the player wins, or the ghost is in the same space as the player, and then the ghost wins. And so what you're supposed to do in this particular problem is to draw the first two plies of the Minimax game tree. And of course, you remember from doing the Russell and Norvig reading is that the terminology in game design is a little bit weird, and we say that each go from a player and then from the opponent, those each count, those are each if one ply or a half move, so that when everybody gets one turn, you've gone one move. So in here, I'm asking you to draw the first two plies, so that basically means what happens after what's what are the sub what's the subtree of max and what's the subtree of min. So I've copied the graph down so we can see what we're doing. And oops, and let's see where we're going. So at our root, when we start, we have a max node where, let's see, it says the ghost is at 2B, that's right, and the player is at 1C. Cool. So what are the possible moves? Well, we're starting on a max node, and somewhere up at the top, I told you that the player is max. And so what are the possible moves that the player can make? Well, let's see. The player, it looks like, can just go up or down in this game, right? Just because, look, the player's here. Where can they go? They can go up or they can go down. So I'm going to draw two triangles for the player. All right. So let's see, the ghost is still going to be at 2B, but the player could be at 1D, or the ghost would be at 2B and the player is at 1D. Okay, so that's after the player makes their move. And now we have a min node here, right, where min is going to get to the ghost is going to make their move now. So let's see, if the ghost is at 2B, boy, the ghost has a bunch of places it can move. Well, no, thankfully, yeah, I said the stairs are normal, right? Just treat the stairs as normal. So the ghost can go left or right or up. So on the next ply here, we've got three choices for our max node. The max node we could have, well, the player is always going to be in 1D for this guy. But the ghost, let's see. Sorry, I really should be writing these inside the triangle, but the ghost could be in location 1B, or the ghost could be in location, let's see, 2A if it goes up, or the ghost could be in location 3B if it goes to the right to those stairs, right? So that's what happens if we go from here. Those are the choices that the ghost has from here, right? On the other hand, if we are already over here, the ghost also has three choices, but the player will be in 1D in that case. So we got 1, 2, 3. And in all of these ones, the player doesn't move, so the player is in 1D. And the player is in 1D. And the player is in 1D. And in the first one, the ghost could move to 1B. The second one, the ghost could move to 2A. And the third one, the ghost could move to 3B. So that is 2 plies or 2 half moves of this tree, Minimax tree. Okay, there's actually a video solution to this problem, the problem 2, that's really very nice. So I'm just going to leave it to you to watch that one. But let's look at problem 3. Consider the zero-sum game tree shown below. Triangles that point up, such as the top node root, represent choices for the maximizing player. Triangles that point down represent choices for the minimizing player. Outcome values for the maximizing player are listed for each leaf node, right? So it's a zero-sum game, which means that that if max is getting 10 points, if it for this, min is getting negative 10 points. So we really want to, max wants to get the most points, min wants to get the least points. Assuming both players act optimally, fill in the minimax value of each node. So let's just take a look. This is a min node, so it's going to pick the smallest of these guys. So it's going to pick a 3. It's going to pick the 3, right? Because that's the smallest. On this second one, it's a min node. Min is looking at the 2, the 15, and the 7, and min is like, well, the 15 score is really bad for me. The 7 score is pretty bad for me, and the 2 is much better. So we get a 2 there. And similarly, for this last case, min looks at the 6, the 5, and the 4 and says, okay, well, if I get to choose, I'm going to pick the 4. And now we say, all right, well, what would Max choose? Of course, Max wants the biggest score. So Max says, okay, thinking ahead, you know, I knew min, if min was perfect, would pick 3 here. Min will pick 2 if I go there. I mean, there is a 15 there, but there is no chance that Max is going to get 15 because as soon as it picks this root, min is going to pick the 2. So Max says, well, I could get a 3, a 2, or a 4. I guess my best bet is to go down to the right because then I will get a 4.